So I'm gonna try to solve this problem. Count number of pairs given the zero index. Let me quickly read the problem statement and I'll start solving that. So the first the first idea I have in mind is brute force and have like every possible pair of numbers and check if it's like less than lower and upper and if it's higher than lower, higher or equal than lower, and less or equal than upper, then increment the counter. But again, like the complexity is like length 10 to the power of 5 to length squared, gonna be 10 to the power of 10, so it's not acceptable right now. So what I want to do, count number of pairs. So I wanna think about like if I can sort somehow them, and will it affect the solution? So if I have this, let's say I have like this numbers, so 0, 1, 7, 4, 4, 5, and then the pairs like that, and the lower is gonna be lower bound gonna be 3, higher upper bound gonna be 6. So I need to find all the pairs, and there's just six pairs that lie within this one range between 3 and 6, so it's gonna be 1. So I'm gonna like do n squared algorithm. So with 0 and 4, 0, 4, and then 0, 4, and then 0, 5. Then with 1 it's gonna be 1 and 4, 1 and 4, 1 and 5. With 7 it's gonna be nothing because it's already out of the bound. With 4 it's gonna be also nothing. With 4 it's gonna be nothing. With 5 I don't count because like it's the last one, so I need to max go to the last 4. So it's like 3 plus 3 gonna be 6 pairs. So I already see some kind of optimization how I can do that. So I can start with like I can sort those numbers. So I can I can sort them and do and have like 1, 0, 1, 4, 4, 5, 7, and then I can start counting pairs from the one that's from the one that's yeah, from, let's say, from like basically 0, and I need to go and do binary search. Where should I stop? Here, and that's gonna be the like binary search for the exactly location when it's gonna be the last value that will get 0 plus x less or equals 6. So the last value of that one gonna be 5, and I can calculate the number of pairs. It's gonna be 1, 2, 3, 4, 5 pairs already. So I do the same for the 1, and I do a binary search for this x. That's gonna be 1 plus 6. The last x, that's gonna be 1 plus 6 less than or equals 6. So this one gonna be 5. So the number of pairs, that's interesting. So number of pairs. So I need to also, okay, so I need to do binary search for the lower bound and binary search for the upper bound. So in case of, basically do two binary searches. So for the 0, it's the lower bound, it should be the first, let's say y, that has a greater, that is greater or equal than 3, and that's gonna be the first y in this equation that's get the y in this equation, so that this equation is greater or equal 3. So I need to find the first y. So in this case, first y gonna be 4, and then the last x in the next equation, so x equal 6, gonna be 5. So here I record like 3 values to result, and then I start from 1, and again I find with binary search, try to find with binary search this lower and upper bound. The lower bound gonna be this one, and the upper bound gonna be this one again, the same. So it's gonna be also plus 3. And when I jump to 4, I won't be able to find lower bound, so I exit right immediately. So the time complexity gonna be n log n for the sorting array, and then for the for this doing these operations, finding lower bound, upper bound for every n, I'm gonna have this binary search log n, and then yeah, so the total time complexity gonna be O of n log n. I don't know, like, if it's like, I'm thinking right now if there is like other solution for this problem than binary search, and it is like maybe there is a linear solution, some dp plus linear. So like, if I sorted all the pairs I don't know. Let me solve this with binary search, and then I'll try to come up with, maybe think about if there is a better than binary search, or maybe I will just check the editorial and see. And check the tutorial and see if there is alternative ways to solve this problem. So let me code it. So I'm gonna have arrays sort, and then nums, and then I'm gonna for the every so I'm gonna have long res equals 0, and then the end return res, and then I wanna have this point I equals 0. Then I'll have this I less than nums length I plus plus, num length minus 1, and I wanna do the binary search into lower equals bs lower, and then nums, and I want to have bs lower, and then I have bounds between I plus 1, and then so I want to search the target. So if I add I plus 1, and then let's say nums length, and let's say current gonna be nums I, or I can just get it from okay, let's say nums I. So, and then I'm gonna have the similar binary search function, but for the upper bound. And I wonder if I can like write the same binary search function for the lower and upper, and then it's gonna be L U, and then I wanna have result was equal upper minus lower plus 1, and this gonna be it. And then I need to write down the binary function private int bs lower, say bs, okay, bs lower, and then now int nums, then int current, and then int lb, and then int, and here like length minus 1, and here length minus 1, and then int upper bound. Let's say lower bound and upper bound, and then I'll do this. So for the lower, I need to find the, so I'll have the two indexes int good equals u bound plus 1, and then int bad equals l bound minus 1, and then I want to have while good minus bad greater than 1, I'll do int m equals bad plus good minus bad over 2, and then I'll check if nums m plus current, and then int. So I need to here only for the lower bound, yeah, L bound. If nums m plus current greater than, if it's less than L bound, I wanna have bad equals m, else good equals m, and then I wanna return good, and then I wanna check bs upper, the same function, bs upper upper bound. So like I wanna have like index, okay, let's say lower bound, and then int s start int, and so start here plus 1, and here minus 1, and then here int start int end, and then start plus 1. Okay, and so I want to have end plus 1, and then start minus 1, and then end plus 1, and here start minus 1, and then if good minus bad greater than 1, L index u index, and then if good minus weight greater than, well, So if good minus bad greater than 1, while it's greater than 1, I'll have bad as equals middle, and then if nums so if nums is so I want this to be greater or equal, so I want it to be if nums is greater or equal upper bound. Good equals m, else bad equals m, and then I wanna return bad, something like that. Can I run it? Lower, upper. U index, L index. Okay, that's it. Seems like there is a better solution. Binary search, okay, that's the interesting one. 2 pointers. Oh wow. So 2 pointers also possible. So let me think about if I can solve it with 2 pointers. So like how much time? So let me check what is used here. Yeah, also I guess 2 pointers approach. Let me turn on my headphones. No, I can't hear it, but it seems like it's a binary search approach. So let me try to do different 2 pointer approach here. So if I do 2 pointer approach, what's gonna be the result? So 2 pointers. Shall I sort it? I guess I should sort it. And then, but again, like 2 pointers. I need to figure out when I need to move the left pointer and when I need to move the right pointer. So if I let's say I have like one like sorted array 1 0 1 4 4 5 7, And let's say I have this, I move the, so I initially like left pointer in here, and I move the right pointer until I, the pair, until the what? Until it's equal to the, until it's within the lower and upper bound. So let's say move the right pointer here, so the sum here is going to be 1, then move left and right pointer here, the sum going to be 4. Oh, I move it until like it's less or equal upper, until it's like less or equal upper. So I move the right pointer less until it's less or equal upper, so until it's like less or equal 6 in this case. So it's, in this case it's 1, now it's 5, and then...
Right, that's hard. Okay, I will be out. It's good to hear from you.
2
Right.
pointers.
Bye.
Right. Okay, so like it seems like 2 pointers also a good approach here. So let me try to solve it. So like 5 sliding window gonna be 5, and then I'm gonna try to do like next step on the next one. So every time I have a window, so I need to somehow record the result. Yeah. And every time it's kind of within the bounds, I need to record like result plus 1. And then if, yeah, so like in this case, I move the left bound, so like here, like the result was 1, and then I move the right bound. I was moving the right bound, so the now like result is 5. I should increment plus 1, and then I move it to the 4, and now result is not 1. Like now result is like what, 9, and it's out of the bound. That's why I need to move the left pointer. So I move it until it's like equals, until it's greater or equal the upper bound, the lower bound, the sum. No, actually no. So like, so what confuses me here is like this lower and upper bound actually. So like, let's say I was moving here, so like it was like 1 and then 5. So if this is 5, it should be counted as like plus. What? What do you want? What?
I want to go already so I can play.
How about which movie?
I want to movie.
Okay, bring me the laptop.
The charged?
Yes. Zlata, come here. You.
Hey, guess what I can watch a movie?
So I will need somehow to figure out how using 2 pointers record these pairs. So as soon as I have, I assume I should move the left pointer, move the right pointer. As long as. So the question is like. Okay, so I should move the right pointer when the top 2 numbers, neighboring numbers, are less or equal upper. So in this case, really? So let's assume I move like here, it's gonna be +1, here it's gonna be +5, and here it's gonna be +8. So like I stop like at this number at 4. And then I need to move the left pointer as long as this is less than lower, like 2 neighboring cells, 2 neighboring like numbers are less than lower. So I move like 0, 1, okay, move it to here. No, actually that's not true, that's a bad idea. So the total sum is not good one, and also the like total sum is not good one because it doesn't show anything. The neighboring cell is also not good strategy for moving left and right pointer. So I need to figure out like how I can like define the range where like all pairs lay within this lower, between the lower and upper bound. If all pairs lay within this range, it means that top 2 not really top 2, that's not necessary. Okay, so I'll have this kind of reference number, and I have like 2 pointers for this one, and oh yeah, so like if I'm like I have this reference key, so initially I have this reference number like 0, and I have like lower pointer, I move the lower pointer, left pointer until this reference number plus number after left pointer is less than lower. So 0 plus 1 less than lower, can I move the left pointer? 0 plus 4 is less than lower, no, so I stop right here for the lower. And then I move the right pointer. Let's say I have this right pointer. So I move it until starting from the, let's say right, I had the right pointer, and I move the right pointer until the this number plus the number under the right pointer is less or equal upper. So I move like 0 plus 1 less or equal upper, yes. 0 plus 4 is less than equal upper, yes. I move it to the what? To the next one. 0 plus 4 also less than equal upper, yes. And then 0 plus 5 not also less than upper. And then and 0, okay, so 0 plus 5 less than upper, but 0 plus 7 not. So I stop with the right pointer here, and I add to result whatever differences there. Then I move the reference number to the next one, and it means that if the reference number is increasing, means that lower pointer should go like to the right, and upper pointer should also go to the right. And I don't need to restart it over, but I just need to move them like further to the right. Like I check 1 plus 4, is it greater than and it's also like right point, like left pointer should be like greater than the reference number. So I move them. Do I need to move 1 plus 4? Is it like less than, is it like greater or equal than lower? Yes, it's greater than equal like 3. So I keep it there. And then the right pointer, is it like 1 plus 5 less or equal 6? Yes. So I try to move it, and like next one is not valid, because 1 plus 7 gonna be 8, that's greater than 6, so I'm gonna keep it there again. So I'm gonna be again plus 3 because the delta, and then I move the reference number. So the reference number gonna be now 4. The left pointer gonna automatically switch to the left, to the right. I mean to the right, and then I start again. Like, can I move the left pointer? So 4 plus. First, I need to check if it's like valid one. So 4 plus 4 is already greater, so I exit. Because 4 plus 4 is 8, is lower bound already, lower current bound is already higher than lower, lower input, so I just exit. So their idea, so this one, I'm gonna move left and right pointer just once, so the time complexity gonna be 1 O of n. So it's like a little bit better than the previous solution. So let me try to code it. So I'll have this int left pointer gonna be 1. So first of all, like time complexity gonna be like not O of n, because like I have like 30 initial, so it's gonna be O of n log n. So I'll have this int left equals so first of all I need to sort arrays, sort nums, and then I need to go of int left equals 1, int right equals 1, and then for int I equals 0. So it's gonna be a reference number. I'll have this, let's say I'll have nums int n equals nums length, and then I'll do this reference number cycle, and then for int I equals 0, I less than n. Okay, so and then you need to check if so while left less while left plus 1 less than n, and So we need first left equals max left, and then I plus 1, and then while L plus 1 less than N and car, so like nums I plus nums L plus 1 less than lower, I wanna do L plus plus. Okay, I do L plus plus like this, and then if L is equal N, I'm gonna break, and then while okay, also for the right equal max right R plus 1 or I plus 1, and then while R less than N and nums I plus nums R less than so R plus 1, well, is this so I'm gonna have this R equals, let's say R is equal just max here, and then if R plus 1 less than or equal upper, then I wanna do R plus plus, and then if left is less than or equal right, then I wanna res plus equal right minus left plus 1, then return res, something like that. Let me run that one and check. Okay, long as equal 0. Nope. So it starts from this one. Let's say 0 initially. So while L less than N, so let's check for what we got for the first index. And line right plus right, okay, left plus left plus right plus right. Print. So what we've got for the, let's say, system 4 and I equal 0, I let the nums length plus and then system out print then nums I, then system out print and then I wanna try to figure out, like, am I sorting right? One, okay, plus. It seems like I'm sorting right. And then, yeah, the first left and first right. First left. So left 2, right 4. 0, 1, 2, 3, 4. Okay, makes sense. For the 1, 2, 4. For the what? For the 0, 1, 2. For the 2. So I have nums I plus nums L if it's less than lower. Is it less than lower? 4 plus 4, 8. Okay, so 3, okay. For the right B. Right was 4. So here should be like break. It's not like kind of beautiful solution. So I'm thinking right now how I should improve this solution. So it doesn't do anything. Okay, if nums I plus nums R is already greater than upper, then break. Will it work? It will work for the first one, but it won't work for the second one. Okay, if nums I plus nums R greater than upper, then break. No, it doesn't work for this one. So it says 11. I wonder where it's breaking. So we have like at 5, let's say index I plus I plus L plus R. So whenever I'm jumping on this 5, I need to print. Oh, I break instantly. Okay, so the reference number, so for 1, so whenever I move, so it's I should decide what side should I go, left or right. So in this case, I checked like for the first number, left was out of the already out of the okay, so left can go to the left and right can go to the right. That's interesting. I didn't catch it. So the rest should be like in this case 1, 2, 5, 7, 9. So I have like for 1 left pointer already like at 9 and like I'm breaking right there. But the problem is that as soon as I move the reference number, the left pointer so the question is how I should affect how like moving the reference number affects the left pointer and the right pointer. So if I already have like some left pointer and right pointer somewhere, like if I move the reference number, so before that was the condition nums I plus nums left was greater or equal lower, let's say LP, and then nums I plus nums right pointer was less or equal upper. So if I change the reference number, so if it's increasing, it might not be the what? It might not be the right one actually. The right idea to move it to the left also. If I'm increasing that one, I should decrease this one. So like reference number go to the right, and left pointer should go to the. So reference number go to the right, and left pointer should go to the left. Because I'm trying to balance it. So initially I should find the left pointer, and then every time I change the reference number, I should try to expand it, and it should be not. So left pointer go to the first to the right and then to the left, and the right pointer always goes where. So if I'm increasing this one side, does it mean that the right pointer also should go to the to the left? If I'm increasing this one, I should balance this one by decreasing, and I only can balance it by going to the right, to the left, I mean. So something like that. Let me quickly check the solution here, what they talk about. Solution. Binary search, okay. 2 pointers. So, oh, okay, so left goes to the. So, okay, oh, that's an interesting one. Okay, I guess I missed it. So I'll take it as a offline exercise for myself to check the solution. I was thinking that the reference number plus this left and right, but actually like it's just a sum of left and right for the lower bound. Yeah, that's really interesting solution. Okay, so that's gonna be it. I'm gonna wrap it up.